In this video, we're going to take a look at all the different ways in which we can arrange different letters or different things in a given situation. We're going to do that by taking a look at or thinking of each problem as the number of different ways that we can assign labels to something. In this formula, n factorial divided by r factorial for each of the different types of things that are undistinguishable, n factorial, this represents the number of ways to arrange all the items. So all the items given to you, n factorial will represent the number of ways that you can do that. R factorial down here, those represent the number of ways to arrange the repeats, or the things that I can't tell the difference between. So if I take a look at this first example, let's find the number of ways that we can arrange the letters in Roselle. In Roselle, there are 7 total letters. So that means there are 7 factorial ways that I can arrange all those letters. But there are 2 E's, and there are also 2 L's. Well, I won't be able to tell the difference between the L's or the E's. So then I'm going to divide this by 2 factorial times 2 factorial. This gives me a total of 1,260 different arrangements of these letters. And it excludes, if for instance I had just switched these 2 L's around, it excludes that option. In the second example, I want to find the coefficient of x squared y to the third of that term in the expansion of x plus y to the fifth. In this particular example, we've actually seen this before, and we saw this when we did our binomial expansions, and in that example, we would have said that it was 5 choose 3, where 5 came from the exponent on our binomial, and 3 came from that last exponent on our last variable. In this particular case, we want to interpret that so we can bring it back to how it relates to assigning labels. Well, this formula is the same as 5 factorial divided by 2 factorial, or 5 minus 3 factorial, times 3 factorial. Well, if I notice here, this compares to this 2 and 3 are the exact same as the 2 and the 3 of my exponents. This will give me a total of 10, and so my coefficient for this term would be 10. Translating that to example number 3, I now want to find the coefficient of x to the third, y to the fourth, z to the fifth in this expansion of x plus y plus z to the 12th. Well, I really don't want to have to multiply this out 12 times just to figure out what the coefficient would be on this term. But I can use my labeling and the similarity to example number 2 to figure it out. The important key factors here are the exponent on now my trinomial, and each of these exponents on my variables, which can be considered repeats. In this example then, I know that my 12 factorial are all the possible different ways of arranging this trinomial multiplied out, divided by, I'm dividing out the repeats. So 3 factorial are the number of different ways to repeat x, then 4 factorial, number of different x repeats, and then 5 factorial. If I calculate this gives me a total of 27,720. This would be the coefficient of this term